Today we are starting exercise 2.1 of unit 2. Before starting, we must know the concept of scientific notation and standard notation. So for this, we first know the definition of scientific notation, what it is. Scientific notation is basically a short way to write very large or very small number using power of 10. By using power of 10 we can write scientific notation. Steps involved in writing scientific notation. First step is that place the decimal point after first left hand non-zero digit. After first left hand we have to place the decimal points. Step number 2 is count the number of digits moved by the decimal point. Step number 3 is if decimal point moved to the left side, exponent always positive, and if decimal point is moved to the right side, exponent is negative. So we will solve an example to understand the concept of scientific notation. The question example is convert 0.05432 into scientific notation. So we have to convert this standard notation into scientific notation. How we can solve it? Here you can see the first left hand non-zero digit is 5. So we have to move the decimal point after 5. And counting the number of digits moving to the right side are 2. As we move to the right side of the decimal, so exponent should be negative as we read above, that moving to the right side power or exponent is always negative. So how we can write it in scientific notation? 5.432, counting number to the right side are 2 and exponent is moving to the right side, so its power is -2. Now what is standard notation? A number in its ordinary form using digits like, examples are 4500 and 0.00067. These numbers are written without using power of 10 and they are in their ordinary form, so we call them standard notation. Now solving an example of conversion into standard form. Here a scientific form is given. To convert it into standard form, we can see the exponent or a power is negative. It means that we move to the left side of the digit 8.99 and we place 5 digit to the left side 1 2 3 4 5 8.00. so as we move to the left side, so we have to count 5 digits moved by the decimal point, that are 1 2 3 4 5. To have to place this decimal in that point, how we can write it in standard form is 0.0000899, which is a required standard form. As decimal is moved to the left side, so we have to count 5 digit moved by the decimal point and then write decimal at that point. Exercise 2.1, question number 1 is write the following in scientific notation. First part is 0.0005347. So we have to write it in scientific notation. First condition is that we have to place decimal after a very left hand non-zero number. Here 5 is the first left hand non-zero number. Left hand non-zero digit. So we have to move decimal after 5 as it is the right side of the decimal. As we move to the right side of the decimal, so exponent should be negative. This is the right side. Exponent should be negative. Now counting the number of digits to the right side, 5.3407 multiply 10 power, as counting the number of digits are 4 and we move to the right side, so the power is 10 power minus 4. This is the required scientific notation form of the given question. Part number 2 is 534,000. So we have to move decimal after first left hand non-zero number, that is 5. As there is no decimal in question, so we assume that it is after last digit 0. So we move this decimal after 5. As we move to the left side of the decimal, so exponent should be positive. It is a left side. Exponent should be positive. And counting the number of digits to the left side, we write it in scientific notation as 5.34 multiply 10 power. Counting the number of digits to the left side are 1, 2, 3, 4, 5, 6, 7. As it is left side, so power is plus 7, 10 power 7. This is the required scientific notation. Question number 3 is 0.000000012. We have to convert it into a scientific notation. Here you can see the first left hand non-zero number is 1. So we have to move the decimal after 1. As it is the right side of the decimal, so exponent should be negative. It's the right side of the decimal, so exponent should be negative. So we write it in scientific notation as 1.2. Now counting the number of digits to the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the scientific notation form, 1.2 multiply 10 power minus 11. Next question is 2.5326. As first condition for scientific notation is that decimal should be after a first non-zero number. Here decimal is already at its place, so we can write it as in scientific notation 2.5326 multiply 10 power 0. As we know that 10 power 0 always equals to 1. So this is the scientific notation form. Question number 2 is write the following in standard notation. Question number 1 is 9.067 multiply 10 power minus 5. Here the exponent is negative, so we move to the left side of the number. So we add the 0 to the left side of the number, that is 1, 2, 3, 4, 5. Now add the number which is 9, 0, 9067. As decimal is between 9 and 0, now we move to 5 places. 5 places count to the left side, that 1, 1, 2, 3, 4, 5. Now move this decimal to this place, and the standard notation is 0.0000967. Question number 2 is 5.64 multiply 10 power 0. Convert it into a standard notation. As we know that 10 power 0 always equals to 1. So the standard notation is 5.64. This is the standard notation of the above scientific notation form. Question number 3 is 6.53 multiply 10 power minus 6. As exponent is negative, so obviously we move to the left side of the number. So we add 60 to the left side of the number. 1, 2, 3, 4, 5, 6. 653. Here the decimal is between 6 and 5, so we count 5 digits to the left side. Counting 6 digits to the left side, 1, 2, 3, 4, 5, 6. So decimal is placed between the first two zeros. So the standard notation is 0.0000653, which is the required standard notation. Question number 4 is 3.1415 multiply 10 power 9. As power exponent is positive, so we move to the right side of the number. 3.1415, add zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. As it is to the right side, so we count 9 digits to the right side and add the decimal. Counting right 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now place this decimal to this side by counting 9 digits to the right side. So the new standard notation is 3.314150000. This is the required. Question number 3 is simplify the following by converting into the form indicated. The first part is 563.71 in 10 to power minus 3 multiply with 2.54 in 10 to power 4. So we have to convert it into a scientific notation. As we know, the first condition for scientific notation is that the decimal point should be moved after a first non-zero number. First we multiply the two numbers 563.71 multiply with 2.54, combining the powers of 10 minus 3 and 10 power 4. By multiplying the two numbers, we get the answer 1431.8234. As by product rule of basis same, we add the powers minus 3 plus 4, that equals to 1431.8234, 10 to power 1, 10 power 1. So in scientific notation, decimal must be moved after a first non-zero number. Here the first non-zero number is 1, so we move this decimal point to between 4 and 1, after 1. As it moved to the left side of the decimal, so the exponent should be positive, and counting the number of digits moved by the decimal point are 3, so we write it 1.431823 10 raised to power plus 3 into 10 power 1, that equals to 1.431823. By product rule, all 10 power become 4. So this is the scientific notation, required scientific notation form. In question number 3, that is 2.549 multiply 5067 multiply 10 power minus 3 divided by 10 power 3. So we have to convert it into a scientific notation. First, by negative power rule, we can write 1 divided by 10 power 3 equals to 10 power minus 3. Now writing it, 2.549 multiply 5067 multiply 10 power 3 into 10 power minus 3. Now multiplying these two numbers, we get the answer 12915,783 multiply 10 power. By product rule, power become minus 6. 12915,783 multiply 10 power minus 6. As we have to convert it into a scientific notation, so first we have to write this in scientific notation, this number. So we convert 12915,783 in scientific notation and assume the decimal is after 3. Now we move this decimal after 1, which is the first left hand non-zero number. So we move this after 1, between 1 and 2. As it moves to the left side, so exponent is positive. Exponent is positive, and counting the number of digits to the left side, 1 2 3 4 5 6 7. So we write it in scientific notation as 1.2915,783 multiply 10 power 7. Now write this scientific notation in equation number 1. We get answer 1.2915,783 multiply 10 power 7 multiply 10 power minus 6. So again, applying product rule law, we get power as 10 power 7 minus 1, 6, which is equals to 7 power 1. So the final answer in standard notation is 1.2915,783 multiply 10 power 1, which is the final scientific notation. So in question number 4 part, there is a number given in scientific notation and we have to convert it into a standard notation. As we know that exponent is positive, so we add the 0 to the right side of the number. So we add here zeros 1 2 3 4 5 6 7 8 9 10. As before, the decimal is between 0 and 9, sorry, 0 and 0. So we count here 10 digit, 1 2 3 4 5 6 7 8 9 10. So here we place the decimal and writing it again, double line, double 8 and triple 0, which is the required standard notation. And the final answer is double line, double 8, triple